Hello everyone, welcome to the course of Database Management Systems. The code is KBM IT04 for the specialization paper IT students, MBA IT students. So today in this session we have discussion on some of the topics which are in Unit 1. Topic of discussions are Introduction to DBMS, Organization and Components of DBMS, Advantages of DBMS, and database models and how the data get organized in some database. It's called Relational Database Model, Network Database Model, Hierarchical Database Model, and Semantic Database Model. So this is the overall topic discussion in this video. We can learn the basics of database management systems. So let's start with introduction of DBMS. So if we say introduction to DBMS, here is some points. Database management system is a software tool or set of tools to effectively organize the data in some database. It allows to create, retrieve, update, delete, and manage the data in the database. Some popular databases available in the market are Oracle, MySQL, SQL Server, DB2, etc. Some more databases you may be heard about your say MongoDB, Cassandra, and so many other databases we can have in the market. The point is how DBMS organize the data. It's called organization of DBMS. Every DBMS is organized generally in three levels of architecture. One is called external label, then second one is called as conceptual label, and third one is internal or physical label. External label shows the relevant database content to the users as per requirements. So different users can see the different data at the same moment of time. This is called external label or the user label. Second is called conceptual label, which describe how the database appear to the users conceptually and the relationship between various data tables. And here we manage the records, and those records are accessed by the users as per their needs. And the last and lowest one is called internal or the physical level. Internal level describes how the data is actually stored in the database, or the physical level, or the disk. So we have the three views: external level, conceptual level, and internal or the physical level. This is how the database gets organized by some DBMS. We can show this graphically also. If we see the graphical view of this, you can see here. External label is for the user label, where the different users can view the different data from the conceptual view. Conceptual view actually have the contents of records based on certain schema. And the internal label is the internal view which contains the really stored the data on the disk. This is called stored database. So there are the three views. The data gets stored on some database, and from database until we go to conceptual view, conceptual view goes to external. So different user can see different data at the different moment of time, the same moment of time. And here are the components of DBMS. Every DBMS consists of 5 core components. They are hardware, software, data, people, and procedures. If we say about the hardware could be your personal computer, your laptop, your server, your virtual machine on some cloud, so and some more devices. Software is basically a set of tools to manage and access the data. Then we can have the data itself, the data along with the description of data that we call schema, and the people who manage the data and who use the data. There could be database designers, there could be application programmers, there could be end users, some more people in the system. Then there are the procedures, how the data get organized. Some set of rules are required. So some set of sections or rules to use the data in the database. So these 5 core components make the DBMS. So we can define hardware, software, data, people, and procedures. They're the 5 core components of DBMS. Let's see what is functions of DBMS. What's a DBMS can do? So DBMS offers several functions which help us to overcome the problems associated with the flat file systems. So if we can know about the flat file system, there are some set of files. If you can remember some languages like C programming language, when we have stored the data, they store the data in the files, like text files or something. So they could be in binary format, they could be in textual format, but they like a certain set of problems which get solved by DBMS. Like take an example. So database data management. This is to store, retrieve, and modify the data. We can have the transaction support. Transaction to be successful or not done at all. That means what? So transaction whenever we are adding some data or deleting data or updating some data in the database, maybe the data is not stored in single table, that is stored in multiple tables. So data should be updated or added or deleted all the places or should not be done in any place. This is to maintain the consistency of data. So this is called transaction support, which is one of the very important features of DBMS. Then it's called concurrency control, which is simultaneous data access provided to the users. Take very simple example. You have some database which is accessed by all the students to give some examination, online examinations. So take an example NPTEL, where we can have so many users, the thousands of users concurrently accessing the data at the same moment of time, which is generally not possible in the flat file system, but database offers the concurrency control, which is one of the very important features of DBMS. One more feature is called function is called integrity to maintain accuracy of the data. So which is again the data should be accurate all the time. So it should be accurate. It's called integrity. Then DBMS also maintains the security. So it allows to access to authorized users only. So you can't anybody can't come and just access the data or some user. They need some authentication, some user ID and passwords to access to enter to the system. The security is managed by the DBMS. Then the recovery mechanism of the different data is so nothing is lost. So if something goes wrong with some your operating system, your hardware or something, so even that we should be able to recover our data. The DMA ensures all these kind of things. If something goes wrong with our system or software or operating system or some hardware, so they provide recovery procedures by which we can access that data. Then DBMS also provides a set of utilities like data import, export, logging, user management, backup and restore procedures. So DBMS provides a lot of functions which help us which will improve the productivity of the system. So these are the very basic things that we must be knowing about. Why DBMS? What are the basic objectives for the DBMS? And if we summarize from those functions, we take certain advantages from DBMS. So DBMS offers many advantages. Some of them can be taken. Better data consistency, faster data access, better decision making, better data security, increased user productivity, which is very much required today, better data integration, backup and data recovery procedures. So here is the advantages that we can see, which is very much required today for to manage any data. So let's continue. The data is managed in the four types of databases. Generally, we can have the database organization. So database systems are mainly categorized in four categories based upon the underlying structure used to store the data. So they are hierarchical database model, network database model, relational database model, and semantic database model. So these are the different types by which we can manage the data on the systems and we can use the data and the users can access the data. If we talk about the hierarchical, first one is your hierarchical database model. In hierarchical database model, organize the data in tree-like structures that you can think of your family structure. Data is stored as records which are connected to one another using parent-child relationship. And here there's some example of the information management system from IBM, RIMA database manager, the RDM. So here you can see this is a parent node, then the child nodes, and this child node again can have child nodes. Take an example your family tree where you can your grandpa, then your father, then your uncle, and your sister, your sisters and brothers and others. So it's the same architecture you can think of a hierarchical database model. Then we can have the network database model. Network database organizes data into graph structure in which object type of nodes and relationship type is arc. Take this example. These are the nodes and this is the relationship and this is arc. Each record can have multiple parents and child records. Take this example. This can be connected to this can be connected to this can be connected to this. Take an example of your Twitter, where you can follow one guy and that guy can follow you back also, and that guy can follow other guys also. So this is an example of graphical presentation of the network model. So maximum of your social media sites use of this kind of architecture. So some examples of integrated database management systems, IDBMS, integrated data store. These are some examples for network database model. And which is the most popular one is a relational database model. Relational database model organizes the data in one or more tables. So tables are linked together using primary key foreign key relationship. And the point is, what is primary key and foreign key? If we take this example, say teachers table, with the teachers table with the classes. A teacher must have a unique ID that's called teacher's ID. And every class should have its own ID, it's called class ID. But a class should be taken by a certain teacher. So there should just have this is called primary key. When the unique information we manage about someone is called primary. The teacher ID is the primary information. And when used by other tables, this is called foreign key. This is the way the things get related together. This is called relational. So relational databases are organized with one or more tables. Tables are linked together using primary key, foreign key relationships. Some popular relational databases are Oracle, MySQL, SQL Server, DB2, and so many other databases. This is the main database generally used in the market. Today we can have NoSQL also, which is based without require some like MongoDB, which is not based on relational model, but this is based on document model, but that we've discussed in later videos. And the fourth one is called Semantic Database Model. This is a conceptual data model which includes the capabilities to express information that enables parties to the information exchange to interpret meaning. That's called semantics from the instance without need of to know the meta model. Take an example of last relational model where we need to define the structure or schema. But here we can store the data without specifying the schema. It's called meta information. The ability to include meaning in semantic databases facilitated building distributed database. Distributed database, the database which maintain is copy of multiple nodes simultaneously. So this is one of the best technology available in the market. You may be heard about DLT, distributed ledger technology, or you may have heard about the blockchain. So blockchain is a kind of distributed ledger technology, distributed database technology, where the same data is get managed by thousands of nodes at the same moment of time. Such semantic models are fact-oriented rather than object-oriented. Take this example. The Eiffel Tower is located in Paris. So this is a relation. The Eiffel Tower relation is located in Paris. So this data contain some information, some interpreted meaning, and the interpreted meaning is on semantics. So we can still store such kind of information in databases, and such databases are called as semantic database model. So this is end of the session. You can send your queries on my email ID. This is bhuvneshwar.sharma@abes.ac.in, and we'll continue more and more things in next videos. Thanks.